During the Internet Protocol Stack discussions, we said that each layer provides services to layers above and receives services from layers below. The layer below application layer in the Internet Protocol Stack, or TCP/IP reference model, is the transport layer. So, let's see what are the requirements that some network applications have, and what are the services transport layer can provide to support these requirements. We categorize application needs to throughput, data integrity, timing, and security needs. Providing these services through transport layer to the application layer for applications needing them is possible. For example, file transfer needs the guarantee that there will be no loss in its data transfer. When you receive a file, you want to know you have received the file completely and correctly. That is, there is no data loss and data integrity is guaranteed. Throughput is elastic for file transfer, since as long as you receive the file within an acceptable wait time, you might not worry about rate of transfer and you can consume the file after full download. For the same reason, file transfer is not considered time sensitive. Email and web documents have similar requirements to file transfer, as complete and unaltered data is their most stringent requirement. Text messaging is also similar in throughput and data loss aspects, but it is a little bit more time sensitive for the usage purpose and interactive aspects involved. How about real-time multimedia? If you're video conferencing or on an internet audio call, you require your video conference service to be smooth and real-time. You might not mind a few pixelations on your screen if there are network problems, but you do not want a frozen screen or disconnection on the audio, or delays. These applications usually need a minimum bandwidth to be able to run properly. They can handle a little bit of loss in favor of staying in real-time sync with the source. The delay has also be in order of milliseconds so that the two sides of the video conference still feel real-time and in sync. The same applies to interactive games. However, in the case of stored video and audio, similar loss and throughput requirements as real-time multimedia applies, but the time is less sensitive. In all of the examples we went through, your files, text messages, real-time video conference, and documents, you might have something that might be considered private. Therefore, you might need security services as well. These needs are dependent on each use case. Transport layer of the internet is mainly based on two protocols, TCP and UDP. Among the services we discussed that are required by the applications, TCP and UDP provide some of them. One of the main differences between UDP and TCP is the reliable data transfer, which is supported by TCP and not supported by UDP. So, for applications like file transfer, email, and web documents that we need reliable file transfer, usage of TCP in the transport layer is preferable. Neither of these two protocols provide timing, security, or throughput guarantees. TCP also does additional work for congestion control and flow control, which are helpful in preventing loss in addition to preventing of exhausting the core of the network. This, in return, might affect its timeliness. UDP, however, might be overall faster and therefore preferred for applications where timing is important, but there is no stringent requirements on reliability of the data transfer. TCP is connection-oriented and UDP is connectionless. For a high-level understanding of the concept of connection, let's build on the socket example that we had with doors. Imagine you're sending boxes between two homes, and the doors of the two homes are like sockets to your processes. Connectionless transport is like sending those boxes individually, with each of them having sending and receiving address and delivered through postal service. For connection-oriented, imagine instead of sending them with post, you build a pipeline between the two doors so that when you want to send something from the sender home, you just open the door and put the boxes in the pipe and slide them to the other side. And they're received at the end of the pipe, which is the door of the receiving home, or the socket of the receiving process. Please keep these general concepts in mind for socket programming, but we will discuss the details in the transport layer discussions. Based on these discussions, the table summarizes the preferred transport layer protocols for each of the discussed applications. Since reliable data transfer is important for applications like email, remote terminal access, web, and file transfer, TCP is used for their transport layer. However, for streaming multimedia or internet telephony, reliability of data transfer might not be as important as receiving the data as fast as possible. Therefore, either TCP or UDP could be used with proper mechanisms built around them in the application layer. This table also provides sample application protocol for each application use case and their RFC specification number. We will discuss some of them in detail, but please feel free to check them on IETF website for further details.